File system. Yeah, file system is a very enjoyable chapter because why? You now understand how to damage your file system. Yeah, how to keep your file system clean, or understand two very basic questions maybe in your mind. Okay, it's in my mind during the time I was an undergraduate student. The two questions is, first of all, why I have to press eject button when I remove the USB? Why? Did you ever try pull out the USB without pressing eject?
Always.
I always do that, but how many of you have having problems? No, no, no. So that means the eject button is just a piece of crap, right? You just click and it doesn't matter. But have you tried while you're copying file, you remove it? And you have, so what will happen? Yeah.
If I want to copy a 1 GB movie, and when during
the animation is playing, okay,
yeah, yeah.
then you pull it out.
Yeah, and when I see the USB again, there has been a movie with that.
Still okay?
But there is only 1 minute, 2 minutes, but we can see the.
But you can see those successful copy,
yeah,
but this doesn't appear. Okay, so you are lucky. Okay, I heard there are cases the USB crash. Crash means that when you plug it in, Windows tell you, do you want to format? Yeah. Okay. So one more question is, why you have to press the shutdown button before you shut down the computer? Why cannot you just remove the power? Oh. Yeah, someone has tried, huh? Someone has tried, huh?
Does blue screen count?
No, blue screen don't count. It's normal. And if you have played with some hardware board, right? Hardware board don't have shutdown sequence, right? You even some Arduino or others microprocessor, simple MCU controller. You don't have a shutdown sequence. There's no button or no interrupt that. Yeah, please shut down, huh? Or I will have a problem. But why? For a computer is just a bigger system, right? Why you need a shutdown sequence? It's all because of file system. It's not because of processes. You know how to kill a process? Kill. Yeah, let's kill the process. Okay? So before you kill the process, maybe you have to flush something to the file system, right? Now that's the start of the long story. Yeah, we have to flush data. And why we have to wait? Why we cannot just cut the power? Or I should say it another way around. Why the operating system is so naughty that not always write data directly to the hard disk? Yeah, that's the clue, right? Why? Why is doing so? So naughty. Why you just write it there so that I can just remove them? When someone is my mother standing behind, I was just playing games. Okay, I can remove the power and she don't know what I'm doing, right? It's not. They have to shut down. Yeah, this sucks. Okay, so I understand the problem and I will unfold the entire story inside this part. The entire story is hidden inside this part. From the programmer perspective, we already start to understand what happened inside file system. And the file system, when we disclose all the mystery, it's all about kernel. Okay? So what is the meaning? Is actually the kernel, whether it's allow a particular file system to be plugged into it. So what's the meaning? Can you plug a Mac device, Mac hard disk? Let's say you buy a Thunderbolt device, okay, Thunderbolt USB 3 very expensive hard disk you use in your Mac. Can you plug it in your Windows and use it? No, because it's using HFS Plus. Well, HFS Plus is usually not being supported by any operating system other than Mac. Or how about NTFS? NTFS may have a support in Linux, but not in Mac. How about something common? FAT32. FAT32, although it's kind of a very old file system, what is that? It's around 1996 1997 or 1996, okay, it's being invented, but still you're using it. Do you know where you have F8032? I know Windows. Other than Windows, do you know? Yes, USB. All USB drive using F8032. Any others? How many of you have CF card? No CF card, so SD card now? You have plugged in an SD card in your machines. Then it will reveal that it is F8032. Okay? Most of the small USB device, usually small, I mean below 128 gigabyte, small USB device, all formatted in F8032. So every operating system, I cannot find any exception. Even a Juno knows how to read F8032. Okay? Every operating system knows. Because this module is actually open source. Yeah, there's an open source module for every device. So your camera know how to read write F8032. Then you remember, you plug in a card in your camera, and the camera uses F8032 to read write your card, SD card. Even though you have very old CF card, it's all using F8032. Your iPhone export F8032. Your Android export F8032. And you can try. Just plug your wire in your for iPhone it's different. Okay? iPhone you have to plug in the Windows to test. Okay? If iPhone plug in the Mac to test, it don't show any file system. Okay? So this is about whether a file system supported. And on top of it, now you understand many devices have different file system and it needs some special function for the support. Now how about the upper layer? The upper layer is some system call. Open, read, write, close. Open a file, read, write, read to the device. Oh no, read from the device, sorry. Read from the device and write to the device. And more upper, we have a library called fopen, fclose, fread, fwrite, fcleanf, fscanf, all because there is an F and it's related to file, it's a library call, eventually called this guys. Okay? So this is an overview of file system. Any question? Anything you want to know? Yeah, I'm kind of expert in file system. Okay, our team know how to write kernel driver, invent a new file system, how to format it based on bits and bytes. Okay, to create a new file system. So if you have any question you want to ask, you can ask. Okay, we actually know many things about file system. So the first question I already mentioned to you is actually an OS support FS. Don't tell people that FS is OS. Okay, OS is a big guy. Okay, it's controlled at FS, it's support at FS, or not support at FS. Like Windows don't support HFS plus. Windows don't support extend for. Oh, extend for, I forgot this guy. Extend for is very important. Huh? It's a native file system of every Linux. Okay. So it's about FS and OS. Make sure you know this difference. FS is not OS. Another difference. What's this difference? This difference is many people make it wrong. Whether a storage device equal to an FS. What's storage device? Your USB, your SD card, your iPhone, your Android. Your Android has an internal ROM, right? Internal RAM, sorry, internal writable ROM, something like that. Okay, it's not. Okay, it's not because usually an SD card cannot format into multiple partition usually, but a USB drive can. Okay, you can give your USB drive to me. Okay, I will destroy everything. Okay, and then we format it in a multiple partition. Okay, USB drive is capable of doing that. So then the storage device now become a container that contains multiple file system. Okay, file system. Now today we'll have so many devices. Usually you will break it into partitions, right? Now let me ask you one question. If you're using Windows, okay, Mac people, you don't understand what I mean, okay? If Windows people, you have C drive, D drive, E drive, right? How many drive you have? Who only have one C drive? Raise up your hand. Okay, so who have two? Okay, so let me ask you, maybe you, why you have two?
No. Just the guy selling me this he
Oh, by default.
yeah,
Oh, by default it's 2. How about you?
Similarly by default. But
By default.
I guess it's related to like backup stuff.
Backup, okay? So any people do that, how about you? It's by default or?
No, because one is SSD and another is.
Oh, you have really 2 physical drive. Okay, which, okay. And how many people have more than 2? No one, huh? No one, huh? Okay. So actually later I will explain to you a bigger disk means slower disk. It's because of some management. So a best practice is you chop the hard disk into some reasonable width. Don't have a 1T hard disk, 1 partition. It's wrong. And usually I will do this based on usage. Okay, I have a partition to host my data, my personal data. One partition is holding, let's say I'm using Windows, it's all the C drive matter, the program files, the Windows directory, and others. One more is to put game. Okay, yeah, so that when I pull the hard disk out, no, I don't have any game. Okay, yeah, so it's a cheap department there. Yeah. And then I can play games. Okay, so let's take a look at very high level. We go from high level to low level. Okay. Sorry, I didn't talk about this part. This part we will teach, but in part 2. Okay. This part we won't teach. Why? Because it means I want to write kernel codes now. I write kernel codes to add new support, or write kernel codes to modify existing support. So we don't teach kernel code. So we will teach this layer and this layer. Today, we will start with this layer. And what is the relationship between these 2 layers? Okay, then we will talk about one very important stuff. Okay, sorry, it's not this side. This one very important stuff. Go on. Sorry, here. Okay, if something happened inside the kernel, okay, and if you are impatient, you can take a look at this page. This page 31, maybe I will just stand here to explain this for 15 minutes. And this page is the answer to why we have shutdown sequence and why we have to eject USB drive with the eject button. And this page, okay? And if you find my lecture boring, you go ahead to read this. Or there's already some challenge before it. Okay, some challenge before it. Okay, so I give you this challenge first. Do you know what's the answer? Do you know what is the output of this code, of this program? Tell me what is the output? Ah? You didn't do assignment 1? What is the output? Huh? Is it hello and then 2 new lines? Okay, I just go to somewhere else. Okay. Test.c. Okay, printf. Hello. Someone tell me that it is one of the interview questions. I don't know which company. That company is crazy. Yeah, sorry. Okay, so the same programmer. Compile, run. How many hello? Again, maybe some bugs, huh? Again. Always 2. Yeah, the first time I see this program, I have a doubt. Should I continue teaching OS? Yeah, I have a doubt. Yeah. Should I continue this? Something bad, huh? Okay. Yeah, then I stop and think, and actually I understand what is the problem. Okay? Don't think that this is a chapter 2, one of the any part that I missed. It's actually concerned the file system design. It's about file system. Some file system library call that play the naughty tricks and give you this output. Sorry, this output 1 and 2. Two output. It's about file system. Okay? And give you one more hint. It's about this line. This line has something wrong. I changed the program and let you see it. Okay. Someone tell me it's interview question. Okay? What did I just change? New line. Compile test. How many hello? 1. Just one new line character and make a big difference. We will explain that as well in next lecture. So how about today? Today I will only start a very, very short journey about this diagram and then we'll stop the lecture. So what is this diagram? This diagram tells you one thing, is what happened after you call F open. Okay? Yeah, if you want to understand what happened, okay, you cannot Google. I don't know how to Google that. Okay? You put my program there, you cannot find any reason, any clues, okay? So make sure you stay with this guys here first. So what is F open? F open is a naughty call. Okay? Later on remind me when I talk about memory, okay? When I talk about memory. Actually, you should ask me these questions, okay, when the OS call start. Or you should ask this question when someone tells you about F open. Why F open return a pointer? Why it's just not like a get child return an integer or a check return, or some others like a scanf, okay? Scanf give you a pointer, update a structure or update a variable. But F open is different. It's return a pointer. Can you guess what is the meaning? Can you guess what is the meaning? Why is return a pointer? And what are the similar call that when you after call that, it will return you a pointer instead of some data, some primitive type. Malloc, right? Think about it. Malloc is something that you call, give you a pointer. F open is something you call, give you a pointer. Is it related? Let's take a look. So this is the underlying call of open. So what's open? Open, we will go through a 5-step, very easy. You call for the file system specific call because you open a file, right? It has to understand which file system you're talking about. So how to detect a file system is very easy, very, very easy. Okay? So you can do it together with me if you're using Mac or using Linux. Okay? You can type the command called mount. Okay? It's a bunch of data coming up. Do you have such a bunch of report? Or inside my Mac? Okay? It's also a bunch of report. If you think that it's hard to understand, you can type df. Okay? df is about the availability of the disk. df is hard to see. df minus h is about how many gig, how many Mac available, okay? But I want to have mount, okay? So let's take a look at Linux mount. Linux mount will tell you about, what is this? The first is device. What is the physical device you're talking about? A file system. And the file system having this location is called SDA1. SD means SATA hard disk. So SD, SATA hard disk. A means the first hard disk. 1 means the first partition. Okay? So the first partition of my SATA hard disk mount to the root directory as a file system ext4. So it's based on the directory. When you are in a particular directory, I know what is the file system you're talking about. If you go to some other directory, let's say you are in a C drive, I know you are having NTFS. You go to your, what's that, D drive, okay? Maybe D drive is your USB. Then I know that it is FAT32, okay? So this diagram missed one important point is, based on your current location, we know which file system operations we could we could use or we should call, and then you'll go to the hard disk to find such a file. Okay, so after the search, maybe yes, maybe no. Let's imagine that the search is successful and it will return something to the kernel. So what are the things that being returned? I cannot explain it to you now. Okay, I can only explain to you later, and I give you a hint. The hint is not a hint, it's just a mystery. Okay, you know how to open a file, right? Do you know where your file system will store your file name? Can you open a file and search for file name there? No. Then you should ask yourself, hey, where is the file name? Okay, I have a hello.txt. Where does this store? Actually, it's inside a hard disk, right? Or you cannot search it. So this bunch of data is quite hidden. I will tell you later. And this bunch of data will copy here so that the entire kernel knows that, aha, I find it out. Okay, I know its name. Okay, I know its physical location in which address inside the hard disk I can find the data. So it will create a structure about all kind of information of that file. Then I will create one more thing over your, what is that? The process file descriptor array. We call it file descriptor array. So what is a 0, 1, 2? Later on I will tell you. 0 is standard in, 1 is standard out, 2 is standard error. And usually the last one will be the first open file. The open file that successfully opened will have a file array. It's a file array of quite long. It's more than 1,000 slots. Okay, so put in the free and return free to the open call, and that is the flow of open. And what's the flow of app open? Okay. Sorry, I will skip ahead. I will skip this page later. I will come back. Sorry. So what is app open? App open is just call this guy and go to the hard disk, go to the kernel, and get the free. Okay, I know that, oh, there is a file descriptor number 3 being created inside the kernel, and this point to the array, and, from the file. Then how to deal with this free? It will call malloc. Okay? This naughty guy called malloc to create a bigger structure to hold this free. How can I prove to you that there is a free hidden there? Actually, there's a code. Okay, so I will use a test again. So let's say I will do the following: f open. F equal to f open. I open a hello.txt. Okay, right, so that I can always create it. Okay, so there is a little function called file number, which accept file structure as an input. Okay, you never heard of it. Okay. Okay, so return 0. Yeah, what happened? Return 0. So what this output will be? Free. The file just opened is free. Now I try one more, although I know it is a memory leakage here. Okay, I don't call it F1. Okay, I should do this. Okay, 1. Open one more. 2, 3. Okay, maybe 2, 3. I know we will have a memory leakage because I forgot the previous P. Okay, but previous F. Okay, but I want to show you the number will get increasing. Yeah. So it will keep reusing, expanding the array. Okay. So this array will keep expanding as long as you open more files. Okay. And it is a number inside the kernel. And in the file structure, hey, what the file structure is doing? Why is it so naughty? Because it's want to say something more. How many of you have called fseek before? Fseek. Do you know what is fseek? No? What happened to our education? What? This guy. Anybody used it before? No. Then ask you a question. When you open a file, okay, so let's say you have to go through the file again, and again, okay? So you have to transfer this once and then transfer this again, okay? How will you do it? Close and reopen. Come on. There is a code called rewind, okay? To reposition it back to the head, okay? Or you can reposition it using fseek as you will. You want to reposition the file to a particular byte, let's say the 1000 byte, you can call this call and position it. And who keep track of it? The kernel as well as the file structure. They will both keep track on this change. Okay, so the file structure is actually having many guys inside there, and that's why it's a structure and created by malloc, because it don't want you to have the trouble to create a memory for the core itself. Okay, so there is something that you have missed in the previous. What happened? What if the previous code never talked about fseek? Even data structure? Yeah, data structure usually have a case that